So when we are talking about the reflexes of the spinal cord, one very important structure is the muscle spindle, which is involved in the stretch reflex, which is a very important and very basic type of reflex when we talk about the reflexes of the spinal cord. And in this lecture, we are going to cover the structure and function of the muscle spindle. So we are going to take a look at the structure and the motor innervations of the muscle spindle. We're also going to talk about the sensory innervations, primary and secondary endings, which are actually a part of the sense innervation. And we're also going to talk about the static and dynamic response of the muscle spindle to stretch. So let's start off with muscle sensory receptors. So there are two types of muscle sensory receptors. One is the muscle spindle, which is actually present in the muscle belly itself in the form of intrafusal fibers, which is actually present between the extrafusal fibers of the muscle. And the other is the Golgi tendon organ, which is actually present in the tendon. And in this part, we're actually going to focus on the muscle spindle and its structure and innervation. So here we can see that there is a picture of a muscle spindle. So it is distributed throughout the belly of the muscle, as I already mentioned. It is not present in the tendon, but it is present in the muscle belly itself. So it sends information to the nervous system about muscle length or rate of change of length. So it can be static, which is the information regarding muscle length, or it can be dynamic, which is the information regarding rate of change of length. So in this picture here, we can see that we have a typical muscle spindle. So these fibers, which actually make up the muscle spindle, are known as intrafusal muscle fibers, and those conventional muscle fibers which are actually involved in the contraction of the muscle, they are actually the extrafusal muscle fibers. So in this intrafusal muscle fiber, we see that we have sensory supply by the type 1A and type 2 sensory neurons in the form of primary ending and secondary ending. We also have a motor supply, which is of two types. One is the alpha motor neuron, which actually supplies the extrafusal fibers. And then we have the gamma motor neuron, which supplies the intrafusal fibers. And again, in the gamma motor neuron, we have the two different types of neurons, and we are actually going to take a look at them in the upcoming slides. So the intrafusal fibers can once again be divided into two different types of fibers. So we said that muscle fiber is of two types, extrafusal and intrafusal, and then once again the intrafusal are of two types. So they are of nuclear bag muscle fibers, which is this one, and we have the nuclear chain fibers. Now nuclear chain fibers are, as already mentioned, they are in a chain and they are smaller in diameter and size, and they are usually 3 to 9 in number, and nuclear bag muscle fibers are 1 to 3 in number, and they are bigger. So in nuclear bag muscle fibers, there is an aggregation of nuclei, and they are in expanded bags in the central portion of the receptor area. Whereas in the nuclear chain fibers, the nuclei are aligned in a chain pattern, as we can see in this picture. So this picture, we have a nuclear chain fiber, which is an intrafusal fiber, and here once again we have another intrafusal fiber, which is a nuclear bag fiber. So depending on the type of the nerve ending, there are two different types of sensory endings of the muscle spindles. One is the primary ending, and second one is the secondary ending. So the primary ending is also known as the annulospiral ending, and it is excited by both the nuclear bag fibers and the chain fibers. So talking about the annulospiral or primary ending, we can see now this here is an example of annulospiral because it is in the shape of a spiral, because it winds around the muscle fiber, which is actually the intrafusal muscle fiber. So you can see it winds around both the nuclear bag fiber as well as the nuclear chain fiber. So here we can see that this is a group 1A fiber, and it is an afferent, which means it is taking the sensory information from the intrafusal muscle fiber to the spinal cord. The second one is the secondary ending, and here we can see it is actually in the form of, here we can see it is only supplying the nuclear chain fiber and not supplying the nuclear bag fibers, and these are actually type 2 fibers, and they encircle or spread like a bush, like here we can see now. So these sensory endings are smaller in size than the primary or the annulospiral endings, which are 17 micrometer in size, and these are 8 micrometers in size, and they only supply the nuclear chain fibers. So as we already mentioned, we have the primary afferent and secondary afferent. Primary afferent are also known as annulospiral nerve endings, and when we talk about the excitation of the muscle spindle, it can be through two ways. One is very simple. If we lengthen a muscle, the whole muscle stretches, and the muscle spindle or the interfusal fibers which are present within the muscle, they also stretch, and that leads to the stretch leads to the excitation of the muscle spindle, which then further leads to the stretch reflex. On the other hand, we already discussed that we have a contractile part on both the extremes of the muscle spindle. So at both extremes, because of that muscle spindle contractile part, when the gamma neurons are excited, they cause contraction of those contractile parts, which results in the stretch of the central portion of the muscle spindle, which leads to activation or excitation of the muscle spindle organ, and that leads to the muscle stretch reflex. So the response of sensory endings, as there are two types of nerve fibers, which is the primary and secondary afferents. Then we have two type of muscle, intrafusal muscle fibers, the nuclear bag fibers, and the nuclear chain fibers. So we have two types of responses as well, because in the start of this lecture, we discussed that it can be either because of the change in length, or it can either be because of the change in rate of length, which leads to the excitation of the muscle spindle. So because of that, we have two types: the static response and the dynamic response. So static response is actually just the change in length, and it is a slow pattern, slow phenomena, and it is present as a response to both nuclear bag and chain fibers. And for example, if I stretch my biceps and I keep it in a stretch position, so there would be a static response which would be continuous because of that stretch which is being directed to the muscle. But dynamic response is different. Dynamic response is a time-dependent phenomena, and that depends on the rate of change in length, and it is only perceived via the nuclear bag fibers. And what happens is that as the muscle is moving in towards the lengthening phase, or it is being lengthened, so there is a feeling of stretch, or there is a feeling of lengthening in the muscle, and the muscle spindle detects it, and this is actually known as the dynamic response. And similarly, when the muscle is contracting, that is also known as the dynamic response, and this dynamic response can either be positive or it can either be negative. If the muscle is being lengthened and its length is changing, obviously because it's moving, so that is a positive dynamic response. And when the muscle is actually moving towards its origin, the insertion is moving towards its origin, and the muscle is shortening, so there is once again change in length. So there is a dynamic response, but that is a negative dynamic response. Another very important thing to understand is that dynamic response is only present until the muscle is moving. As soon as the muscle stops moving, the dynamic response stops. However, the static response may continue in that state. And then we have the gamma fibers, which actually contract or cause the contraction of the extremes of the muscle spindle, which is actually a contractile part, and that actually alters the response of the muscle spindle to a stretch. So in terms of static response, the gamma motor neuron, which is responsible for, known as the gamma S fibers or the gamma static fibers, and in the terms of dynamic response, they are the gamma D fibers or the gamma dynamic fibers. Here we can see them as well. So static gamma fiber, so it is supplying both nuclear bag and nuclear chain fibers, and the dynamic gamma fiber is only supplying the nuclear bag fibers, because static response is related to both nuclear bag and nuclear chain fibers, whereas dynamic response is only related to the nuclear bag fibers. So as I already mentioned that these static and dynamic responses are actually controlled, or their intensity is controlled by the gamma motor neurons, which are the gamma static and gamma dynamic. So gamma static is involved with the static responses, and gamma dynamic is involved with the dynamic responses, which only involve the nuclear bag fibers, and the static response involves both the chain fibers as well as the bag fibers. So how does this actually happen? It happens in a way, if you take a simple example, so whenever there's lengthening of the muscle, there is actually lengthening of the muscle spindle, which actually elicits a muscle spindle response known as muscle stretch reflex. Now, another way of this happening is, even if there is no stretching of the muscle or lengthening of the muscle, the muscle spindle can itself be lengthened and can result in activation of the muscle spindle response. And that can be because of the contraction of the gamma fibers, and that occurs by the contraction of the contractile part at the both extremes of the muscle spindle, which are supplied by the gamma nerve fibers. And when they contract, they actually stretch or lengthen the central part of the muscle spindle, which actually results in lengthening or perceived lengthening of the muscle spindle, and thus activation of the muscle spindle response or the muscle spindle stretch reflex. So at the end, the summary is that the gamma motor neuron can actually influence or in the intensity of static and dynamic response of the muscle spindle. And that's pretty much all about this part of the lecture, and I hope you learned something new out of it. So keep on watching sqadia.com for more lectures like this. Thank you very much.